We are here with another question on probability. It's a very common question. It's a very famous question when it comes to basic of probability. So there is a helicopter which is crashed, and it is likely to have missed somewhere in this region. You can see over here a rectangular region. Now the question is about what is the probability of the helicopter crashed in the lake, which is shown over here. So, how do we find the probability of the helicopter being crashed in the lake seen over here? Please understand. Uh, it's a question where we do not have a sample space which contains numbers like as that of a dice or a sample space such as all the numbers below 10 which are divisible by 2. This is a question where we are going to find the area, and the area becomes a sample space. Because see, the total possible area where a helicopter can get crashed is the whole rectangle. But since we want the less casualty, that's why we are finding the probability of helicopter being crashed in the lake. So the favorable outcome or the event is the area of the lake. So first we'll try to find the area of lake. Area of this lake is, well, this remaining length is 2.5 because this is 2 over here and this whole thing is 4.5. So remaining is 2.5. And the same way, this length over here is 3 kilometers, which is 9 minus 6, 3. So the area of lake is 3 kilometers times 2.5 kilometers, which is 7.5 kilometers squared. Now, what is the area of the whole rectangular region? Because this becomes a sample space for us. Now, the area of lake is 7.5. Area of rectangle is going to be 9 times 4.5, which is 38.5 kilometers squared. Now, probability of helicopter is going to be area of lake over total area, which is 7.5 over 38.5, which is 75 over 385. which is 0.19, rounding off to 0.2. So this is the answer. Next question is about two dice, one blue and one gray, which are thrown at the same time. Write down all possible outcomes. So first question is about, the first part is about writing down all possible outcomes, what we can get after throwing two dices, one blue and one gray. So with this question, with the help of this question, we're gonna understand how to write the sample space, all possible outcomes when it comes to throwing two dices at a time. At the same time, I'm sorry, at the same time when we throw the two dices. So let us write the sample space. Sample space is going to be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Throwing two dice at the same time means on the first die we can get one, and on the second die we can get one. Similarly, on the first die we might get one, on the second one we might get two, like this. And this is how we're gonna write the sample space for this: 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Now we have 3, 1, 4, 1, 5, 1, 6, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 6, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. This is the sample space. The next part is about they are asking the probability that the sum of two numbers appearing on the top of the dice is 8. Now, please understand what is this question about. So basically, when we throw the dice, we get one side which is facing upwards, and we can get either 1, 2, 3, 4, or 5, or 6 on the face which is upward. So when we throw two dices like this, suppose let's say we have uh, 2 on the top face of dice 2, and we have 1 on the top face of dice 1. So if we add these two, we are going to get 3. So this is what the question is asking. What is the probability that the sum of two numbers appearing on the top of dice is 8? Now, from the sample space, we are going to choose the events where when we throw the dice and on the top, we are going to get numbers whose sum is 8. So let's find all the possible combinations where the sum is 8. So we have one over here, another one here, 4 and 4, 5 and 3, 6 and 2. You can cross check your answer one more time. So number of favorable events we have here is 1, 2, 3, 4, and 5. Probability of getting a 8 is 5, total 5 favorable outcomes, whole divided by 36, which are total possible events which are present in this sample space. So 5 over 36. Now, probability that the sum of two numbers appearing on the top of dice is 13. So we need to find P13 basically. Let's try to find the combination where we are getting a sum of 13. Is it possible? I don't think so, because the maximum sum we can get is 12 if 6 appears on the top face of first dice and 6 appears on the top face of second dice. Even in that case, the sum would be 12. So the probability of 13 is 0 over 36, which is 0. Now, probability of getting a number which is less than or equal to 12. So less than or equal to 12 means this is the number, this is the combination where we are getting a sum of 12. And all the other events which are present inside this sample space, if we add them together, we are going to get a number which is less than 12. Like if we add these two, we are going to get 11. This is about 10. Okay, so favorable outcomes over here is, just 1 minute. Probability, let's say we are finding the probability of event X of getting a sum less than or equal to 12. So this is going to be 36 over 36, which is 1. Okay, next we have some questions related to same topic, probability. First one, complete the following statement. Probability of an event E plus probability of event not E. We already know that probability answer for this is going to be 1. Next, the probability of an event that can not happen is 0, such as such an event is called impossible event. The probability of an event that is certain to happen is sure event. Sorry, sure is here. This is the answer here, sure. And the probability of a sure event is 1. Next, the sum of probabilities of all elementary events of an experiment is again going to be 1. The probability of an event is greater than equal to 0 and less than equal to 1. Question number 2. Which of the following experiment have equally likely outcomes? A driver attempts to start a car. The car starts or does not start. Well, the part 1 of question number 2 is definitely a hypothetical one. It depends on the condition of car, but yeah, if we consider this a theoretical question, then a car might get started or it does not start when we try to start a car. So yes, this is definitely equally likely outcomes, these two. Second one, a player attempts to shoot a basketball. He shoots or misses the shot. Yes. A trial is made to answer a true false question. The answer is right or wrong. Yes. A baby is born. It's a boy or girl. Yes. But if we do not consider the first one as a hypothetical one, then definitely this is not a equally likely outcome. Same goes with two. Question number three, why is tossing a coin considered to be fair way of deciding which team should get ball at the beginning of football game? Because the probability is going to be 1/2. If you write the sample space, it's going to be either head or tail. So if player one says head, he has a probability which is 1/2, which is 50%. And the other player probability of winning the case is again 50%. So that's why tossing a coin in a football game in order to decide which one is going to start is completely fair way of starting the game. Which one of the following cannot be probability of an event? Question number four, 2/3. Yes, it can be because uh, i- if we solve 2/3, the decimal we are going to get is less than 1. So A is correct answer. B, negative 1.5. Probability lies between 0 and 1. So no, this is not the answer. 15%, yes, because if we convert 15% to decimal, it's going to be 0.15. Yes. 0.7, yes. Question number five, if PE is equal to 0.05, what is the probability of not E? So we already know that PE, probability of an event to occur, plus probability of event not occurring is equal to 1. So answer is going to be 1 minus 0.05. Next, a bag contains lemon flavored candles only. Malini takes out one candle without looking into bag. What is the probability that she takes out an orange flavored candy? The bag does not contain any candy which is orange flavored. So the probability of getting a orange flavored candy is 0. A lemon flavored candy is going to be 1 because all the candies which are present inside the bag are lemon flavored. So either way you pick any one candy out of the bag, it's going to be lemon flavored only. Question number 7. It is given that a group of 3 student probability of 2 students not having the same birthday is 0.992. So 2 students not having the same birthday. Remember, this is about not having the same birthday is 0.992. What is the probability that 2 students have same birthday? So this is again a case of event and event happening and event not happening. So we can write probability of same birthday plus probability of 2 students having not having same birthday is 1. The probability of having same birthday is 1 minus 0.992. Question number 8. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red? So total number of balls is 3 red plus 5 black, which is 8 balls in total. Now probability of getting a red ball is 3/8, and probability of getting a ball which is not red. For this one, we can actually find the answer using 2 methods. Number one, favorable outcomes of not having a red ball is remaining balls, which is 5, which are black, over 8. So this is one way of getting the answer. Another one is probability of a red ball plus probability of not getting a red ball is equal to 1. So probability of not getting a red ball is going to be 1 minus probability of red ball, which is 1 minus 3 over 8, becomes 5 over 8. Either way, we get the same answers. Thank you.